Day 7 of the 2024 Full Arch Rally was held in Joshua Tree National Park, and on day 7 we did an unusual thing. We didn't go on any of the scheduled hikes, and instead we met Jay Wilbur at the Arch Rock of Joshua Tree National Park to measure it. So here's Arch Rock in Joshua Tree National Park, and Jay Wilbur just noticed this little alcove arch. Thin flake of an arch, but you can see sky through it. So there's a second arch on Arch Rock. Arch Rock, Joshua Tree National Park, and the moon. Okay, this is going to be challenging to measure. Oh yeah, the surface is curved.
Can't really judge it like the other one.
Right.
Might have to take several measurements and take the biggest one.
I can see underneath here it's got it's like a little sheet of rock that fell out.
Yeah.
So it should be somewhere in that point, maybe it's the height.
It's going to be, I'm guessing, from this perspective, that it's in this little lighter paramecium shaped.
This part that fell out.
Yeah, it's probably somewhere in there, but it's hard to say because, you know, it also depends on where you're.
Where your point that you're starting from.
It's just sloping down quite a bit, and it might be over in here somewhere too. I think you're going to have to take 2 or 3 different ones and see which is the bigger one.
Right here.
I'm thinking it's probably towards, I'm guessing based on the slope, I could be completely wrong. It's just, you know, you get perspective issues. It's probably pretty near where that light space comes to a point.
Yeah. Here? Up here.
No, the other end.
Oh, the other end looks lower. It looks like the highest point is in the middle.
Well, yeah, but it's the height above the base that matters, not just the elevation against sea level. It's how far above here it is. And you see how this is sloping up?
Yeah.
And that's kind of level. So I'm saying you might have to measure
straight down from this point.
From that point, and also the one that you intuitively picked. Both of them, and see which is bigger. I don't know. Try to get vertically straight down from it.
It's hard to see that. Is it disappearing? I can still see it.
Yeah, I got it. You're close enough. You're definitely still close enough.
All right.
Yep, you're good.
Okay, I'm touching the ground.
Get that one.
2.997.
Yeah, now try where you thought and see which is the bigger one.
Where the crack was.
Yeah.
Here?
No,
closer to where your knee was.
More, about 6 inches more this way. Yeah, and that's too far. Right there, yeah. If you could see the, can you see it?
No. Is it on? Oh, yeah. It's not on the hand.
I don't see it.
I don't see it at all. There it is. Well, could it be that you're missing? Okay, well, I just went ahead and took a measurement. It's 9 feet 10.
10 inches? 9 feet 10 inches?
9 feet 10 and a quarter.
And you're ready to take a measurement.
Oh, there it is.
And I think
Got it.
That's what everyone says. Like,
9.
I think you're probably about a few inches too high. I'm guessing about 6 inches. So add 6 inches to what you got there.
It's 9 feet 9 and 11/16 inches. So add 6 inches to that.
Rough.
Puts it over 10.3.
Yeah. Yeah. Yeah, so somewhere between 10 and 10 and a half. I'm inclined to go with 10 and a half myself.
Okay.
Well, no, you know, I'm going to take that back. I have a little slope here when I do this, don't I?
Yeah.
Yeah, and there's a slope there, so let's go with 10 feet.
Okay.
You know, that's going to be within a few inches.
All right.
What do you think?
Here comes the heart. Sounds good.
You think, all right.
Now comes the hard part.
Well, now comes the interesting part as far as I'm concerned.
Yeah, trying to get the span.
So the first thing we have to ask is, where are the span points?
Right.
All right, and there's a couple of problems with this, and this is kind of what I wanted to talk about.
Okay.
Before we measure, we have to decide where the span is.
Right.
There's a couple of issues. The first one is right where you're at. You can see is this comes down. Is that where you measure the northern span point? Somewhere in here, because that's where the lintel kind of cracks and breaks open. That's one possibility.
So like in this indentation, does that start from?
Well, that's one possibility, but I think if you look down to your right down there, you'll see that that whole thing is suspended.
Right. Yeah.
So that means it's part of the span still. So we've got to go down to where this crack is. All the way down there. And we're going to have to set some kind of a marker down here to indicate where it's at. That's the first problem.
Yeah. There's more.
The big problem is, what do you do with this boulder? Okay. Is it providing any support to the lintel at all? You know what I'm saying?
Yeah.
And that's really a very interesting question.
It's actually, it looks like it's just horizontally.
Yeah, from your perspective, you can see it better than we can.
Yeah, it looks like it's just lying next to the span, not part of it.
It almost looks to me like the arch is supporting the boulder rather than the other way around.
Right.
Can you go down from there?
There's a crack through it, so I don't know that they're actually.
Yeah, there's a crack there, but right here from there.
Yeah, I just have
This
to
big
look at my back.
boulder.
I'm gonna come up here and look at that view out that way.
This big boulder here does touch the span, but only in here.
Yeah.
There's a gap on the other side of it.
Yeah.
So this is the only place they.
Well, here's the other thing. We've got all these falling boulders around here. Boulder field. There's another example here. If this were actually part of the arch itself and not just a boulder that came in afterwards, I don't think you'd see it on its short end. You see what I'm saying?
Oh yeah.
You're not going to form a boulder like that from erosion. It clearly is a rock that's fallen into place.
That's just
All right.
And I guess maybe rain's brought minerals in, rocks in, so it looks like they're in contact.
It's kind of fused because of the weight,
Right.
but I don't think it's part of the span.
Right.
But that's the first question you have to ask, because if it were providing support, this would be the span input right here.
Oh, okay.
You see what I'm saying? Because the opening ends here.
Right.
All right.
If this was in fact part of the arch.
All right. So now that means if we discount the boulder, which I think we can do, then the span goes, the south end point's over here.
Right.
So that's kind of a really fascinating situation that you have to judge.
So if we could maybe divide it up into 3 measurements, we could maybe
Or
get,
possibly 4.
could get from that.
Well,
end to
actually,
that.
I think
You
we
mean
can
like-
do that for precision, but the more measurements you take, the more error you introduce. What I'm thinking is we try to do something parallel, just along this crack, because this is a really nice straight line that's parallel with the span.
Oh, okay.
We can get a target that's there and shoot from there, and we get a single
So we just
straight
go-
line
so we just
measurement
go
to the
across
target.
front like
Yeah.
this and call that
Yeah.
the span.
The other nice thing about that is the angle will be closer to 0 too.
Right.
So that's my recommendation. Doing it the other harder way has the potential for more precision if you can set up tripods and do all that stuff and get all the angles just right.
Yeah.
That would get higher precision, but every time you do a measurement, you're adding potential for error.
Right.
Now the other question would be, is it possible that the other side is the better side to try to measure the span from?
Well, this is like he was saying, it looks like you can like a level.
We can go look at that.
Well, my concern about that is we're on the bright side of the arch, and that might be hard to see the laser point.
Well, it depends on the target. I think your blue shirt would be perfect for it.
Oh,
I had him bring white reflective gloves.
Oh, that would be even
yeah,
better.
I've got these gloves that are metallized.
Yeah. Okay. So the trick is putting the target here perpendicular to this line and even with the extent of the span.
Right. So find where it's got its farthest extent, and then come parallel or perpendicular to it, and set up a line.
Perpendicular to this line. So
Right.
find the line that's perpendicular this way that would point to the farthest point.
Right.
Yeah.
So
I think the target should be on that side because then it'll be shaded.
that's
Good point. We could do it that way too.
So we'll be shooting the laser from the side that's facing the sun and have the target on the side that's shaded.
I think that's an excellent suggestion.
okay. So
So the end of the span is going to be down here, and you're going to have to
yeah.
get down there and stand probably right there. I was able to do it a couple of days ago.
Okay. So you're checking out the extent that way, and I'll check out the extent this way. All right. So you're perpendicular to the farthest extent.
I wanted to be perpendicular to this
Right.
plane here.
All right. Where is? Ah, shoot.
Well, I could be a middle target.
I think I'm right here.
Okay.
So I'll set up the gloves.
Yeah. Perfect. 53 feet.
Oh, good. 53 feet. Okay. What?
You got it recorded?
This is running.
53 feet on the nose.
Okay.
That's the number I wanted to get. I think you're in the. We don't need to do a halfway point.
Yeah. Yeah. So you want to come over here and see if I got this extent correct?
That's a good idea. Yeah.
I was noticing there, it looks like water bottles are stuck down here at this end of the arch, and I was wondering if there's a way we could remove them, help the park.
It's probably perpendicular. You see how this goes that way? You want to be perpendicular to that,
Yeah.
and you're kind of at this angle instead of this angle.
Okay. So, all right. So,
let me show
so I'm
you.
getting the correct extent. I just wasn't positioning myself correct.
Yeah, you were probably back about 2 feet.
Okay. All right. So
I'm thinking probably need to be about right here.
right in this line right here. Okay. Okay.
So I'm going to take 2 feet off.
Oh, so you're just gonna do it that way?
Yeah,
Okay.
that's easy.
We're not gonna shoot it again. All
I
right.
don't think there's any need to unless you want to.
Okay. And what point on the span are you referring to for the thickness and width?
Sorry.
Minimum, right? Oh, right. Minimum vertical, minimum horizontal.
Be the same place. It could be a different place.
So what would you do? Average?
No, I mean,
Oh, you just take them in the different spots, and that goes.
the minimum vertical thickness is maybe at a different place than where the minimum.
Right. But those would be the measurements, even if they're not matched up physically, right?
It doesn't have to be the minimum point doesn't have to be the same place.
Okay.
Right.
It's just this side of the
No,
It's
yeah,
right about here.
Just
And that's from judging over there.
right. So he thinks it was about 6 feet to the right from where we measured the height.
Yeah. And I don't think you can do that and it would confirm, but I don't think you can get an extremely accurate measurement there.
Uh-huh.
You know what I'm saying? I mean, that's a good way to do it. But
Well, we could give it a try and see what we get with.
I'm gonna head out though.
Oh, okay.
My wife's waiting for me.
Oh, true.
Going down the other side now?
All right. So
It's been great working with you guys.
Okay.
Thank you very much.
All right.
Jay Wilbur of the Natural Arts and Bridge Society, founder and all-around good guy.
It's been a great pleasure working with you guys. Fantastic work. Enjoyed it very much.
Okay.
Have a great day.
See ya.
And we can share
Sure.
results
Sure.
via email.
Yeah.
Okay.
That'll work. All right.
Safe travels.
Thank you. You too.
So So we're trying to figure out the thickness of arch rock in Joshua Tree National Park. We measured from here, which matches the bottom of this part of the span, up to there, which we think may be the thinnest part of the arch. And that's where I held up my hand so that my gloved hand so that it could reflect the laser beam off of it. We got a reading of 1.407 meters. Now we're going to try to do the width. Okay, so Rick is now on top of the arch with the laser measurer, and we're going to try. Jay Wilbur thought right about here is the minimum. Like here? The minimum distance here? Vertically and horizontally. Yeah, right about there. Hand on that side. Oh, maybe I should have done this because I've got the reflective gloves. Okay. Are you far enough across? Oh, okay. Oh, I'm looking at it from an angle. So let me move back over here and see it from behind you. It's just coming up with error. Let me try it again. Okay, a little farther to your right with the measurer. I know, I'm trying to have the beam on the front and then back away from it. You want the picture? Yeah. 1.104 meters. All right. So we just finished measuring this arch rock at Joshua Tree National Park with the help of Jay Wilbur, who's an expert, founder of the Natural Arch and Bridge Society. So we did the measurements he recommended, then we went beyond that and did a few of our own, and we'll see how those numbers come out. So if you enjoyed this video, be sure to like and subscribe.